Okay, so here we're going to do an example of, we're going to be using, we're given a recursively defined sequence. That is a sequence that's defined recursively. The next term is defined in terms of the previous term. It's a recursive definition. And what we want to do is we want to find an explicit function, an, that can, just in one function, an equals, that can give us the same sequence. How do we do it? Well, a1 is pi, so what is a2? Well, a2 is a1 squared. a1 is pi, so we get pi squared. And now we just want to keep going until we see a pattern. What is a3? Well, a3 is a2 squared, so we get pi squared squared, which is pi to the 2, well, we'll put this as 2 squared. What is a4? a4 is a3 squared, but this is a3. a3 is pi squared squared. Then we square this. What is this? This is pi. This is 2 pi raised to the 2 raised to the third. Because again, repeated multiplication, that's what exponentials are, the repeated multiplication, just like multiplication is repeated addition. Okay, so 2 is multiplied 3 times here. Let me just do one more, a5. Well, a5 is a4 squared, so we get this, pi squared 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 squared. Yeah, I could have just squared that, but it's a little easier here for students to see. And this is pi raised to the 2 raised to the 4th. And we could keep going. But now we see a pattern. So now we can get an explicit function, an. We can define it explicitly in terms of n instead of recursively. Well, what is it? All of these, well, this is, so this is pi 2 to the 1. And this is really pi 2 to the 0, because 2 to the 0 is 1. So what is our pattern? Well, we have pi raised to a power of 2. And what is the power of 2? Well, notice the subscript, the power of 2 is always 1 less than the subscript. This is 3, 2 to the 2. 4, 2 to the 3. 5, 2 to the 4. So the exponent is always 1 less, so we get 2 raised to the n minus 1. And now what we've done is we converted this recursively defined sequence as an explicitly defined sequence. That is, an is defined explicitly in terms of n.